this is probably going to slow me down quite a bit, but I've decided to kind of cover what I'm doing here. I'm making a prototype for a strip sander that's going to work on my lathe. I've got I got an idea for an entire line of tools that will be powered with a lathe, and I figured this would be my first one. I was going to do another one before this, but decided to kick it off with this one. It's a little bit more complicated, but it's not the most complicated. The most complicated one that I wanted to do, I think, that I will be doing, is a bandsaw. I was going to make a small bandsaw that's driven by the lathe. Of course, you can always drive it with a small motor too, and that's the point. My original concept here was to make use of the lathe when it's not being used, because I don't know about everybody else. If you're not a regular turner, yours is probably sitting gathering dust in the shop for long stretches of time, just taking up space. So this would be an idea to utilize it for something other than turning. So I got a piece of plywood here, and I need to just drill a 1/4-inch hole in it to mount my top wheel on. And I'll show that in a second after I drill this. Now, this video is not going to be like a lot of the ones I've done before. I'm not going to overly edit this. It's going to be longer. So if you're one of those people that's into the instant gratification, you're not going to get it here. I'm going to leave a lot of this crap in. I don't care how long the video takes to do. It's not going to be as polished. It's not going to be as pretty. I'm actually probably going to upload it at a much smaller size than normal. My internet is expensive, so anything that I upload is expensive, costs me money, and videos like this generally won't make me much money. They're basically for the people out there that enjoy watching this kind of thing. I'm one of them, if it moves along quickly enough, which I'm going to try to do. Wow, my drill bit moved up because it's not tight. There, tighten it up by hand. I started doing this yesterday by gluing up this blank right here. This is the drive wheel, and this will mount to the face plate that's on the lathe. And the idea here is that these two layers of MDF are 3/4, and when they're glued together, they're 1.5. And now what I'll do is I'll cut this out in a circle, roughly on the bandsaw. Then I'll mount it on the face plate on the lathe, and then I'll turn it perfectly round on that. And that'll be the lower drive wheel, no problem there. For the upper drive wheel, I thought about several things. My first thought, of course, was to build a wheel and put bearings in it. And then I got to thinking about what Matthias Wandel did with his, and he used a rollerblade wheel and just cut down on the edge. And I already did that with these ones that I have because I used it on the multi-wheel bandsaw. I trimmed them down like that. But then I got to thinking, do you really need a wheel itself up there, or can you just use the bearings? And so what I did was I took the bearings out of that one. I took the bearings out of another one. I've got 3 stacked here, along with the bushings that go into it, and it fits on a 1/4-inch bolt like this. And the idea is that this will slip through this piece of plywood, which I'll have to hammer in, I guess. I'm gonna get a washer on there first, and then pound that in. So that goes through, and that will guide. I've got several belts here already. I ordered these a long time ago because I want to make another, these are 1x42 belts, by the way. I want to make another 1x42 belt grinder. It won't be a sander, it'll be a grinder that will actually grind metal. So it'll be higher speed and whatnot. So anyway, this is going to guide the top of the belt, and you'll be able to tension it by lifting it up, and you'll be able to adjust the tracking by making it tip like this. So that's the way this works, or this is the way I envision it working. So this will be up here on the lathe. All I need to do next is make a post that this will attach to so that I can do both operations. So here's the belt. It goes up on the thing like that. This goes up at the top here, like so. I added a few washers on the inside of this to space the bearings away from the thing a bit more. And now, see, what you really need now is another arm with another hand to try to get this measured. So if that's stretched up there to the top, and then I measure down, I can see the top of that is roughly 22. So if I make my post 22 inches tall, it'll be tall enough. The base that the posts attached to has to lock into the ways on the lathe here somehow, and I'll puzzle that out after I find a suitable piece for the post. I think maple would be good. I'm probably going to replace this part with maple too. I don't want to make these parts that I'm making right now from good wood. So what I'm going to do is I'm going to find a piece of spruce around here to make the posts with and to make the base. And then I can actually try it out and see how well it works before I commit to it. And that's part of the prototyping process, and that's the stuff that you never see in a build video, all the work that went in beforehand to sit down and actually sketch out what you have in mind, or think about it, or spend time in SketchUp working out the details after you do come up with some sort of a final design. It all adds up, it all takes time. So I'm not sure what the best way to orient this is. I could go this way, which would make it strong that way, and then this attaches to that, or I can go that way. This way will probably be strong enough anyway, and I can always brace it back to the base. I think the base is going to be a piece of plywood screwed onto here 3/4 inch, and then I'll put a brace on the back to keep this from tipping this way, and then I'll put a brace this side that clears this drive wheel to keep it from tipping that way. So something really simple. And then to attach it to the lathe bed itself, I'll just use bolts to go down through. I think that I'll need to be able to adjust it, rotate it slightly so that it will be lined up correctly. The final version of this thing would have something that fits down inside the slot in the bed of the lathe, and that'll lock it in position and keep it lined up properly. But for the prototype, I don't need to go to that extreme. I've got the base, which is just a scrap of plywood, and I've screwed this onto the corner already, and I need to brace that. So I've got a couple of scraps of 1/4 inch plywood. I think that's one of the things you have to figure out during the prototyping process, how strong each part can be so that you don't wind up wasting time overbuilding something. It's always easier to just make it stronger than you think it needs to be, rather than spending a little bit of extra time, and also depending upon your experience doing this kind of thing, in knowing how much strength something needs, how strong an assembly needs to be to work properly and be durable. It's all about durability in the end. You can make something that'll work, yes, but if it falls apart quickly, then it's not much point. That was the deal with my belt grinder there. I know that those types of machines normally get a lot of abuse. So if you were to build that and then set it up, you really don't want to be tinkering with it every 2 or 3 days to try to get it running properly, because it's underbuilt. So better to overbuild it to begin with, and that way it's strong enough to withstand that abuse, I guess you could say. So this is my first time doing something like this, and I don't know if I'm going to be doing it again. It's just something, I came out here this morning specifically to do this, to work up this prototype for this, and I figured it would be interesting if I could document it. Now I can see a problem that I just did, and that maybe this base is not big enough to, I have to try it out to see. That's another problem with making a prototype. You'll often make mistakes that will set you back 10 minutes, 20 minutes, half hour, the rest of the day while you go and cry about it. No, I think it's going to be okay. It'll just catch. Ideally, this base should have been bigger. I had a bigger piece of plywood, but it looked like it was too big. So, and I didn't want to cut it down, not for this. Because like I say, I'm frugal about the materials that I have. If I can use that plywood for something else, which I more than likely can, I'd rather have it a bigger piece than two smaller pieces. So let me know in the comments what you think of this. I know a lot of guys are doing so-called live builds, and that has some attraction to me, but my situation is here, I don't have good internet. It's expensive, so I don't think that I can really afford to do that kind of stuff. So this would be a good alternative, I think. And I'll be able to cut out some of the stuff that I think is kind of redundant. Like driving in 50 or 60 screws, I'll just stop the camera and edit that part out. So this is it, the basic structure for the post and the base, and that'll just sit on the lathe bed. And then, like I say, it'll bolt down to the thing, and then the arm will, I should get a clamp, clamp that on. You might also be saying, well, why are you doing this when your workshop is in such a huge mess and you still haven't finished your miter saw station? Well, the answer is that you get, I can't say you get bored, but you kind of get a little bit fed up with doing the same thing over and over again. And it's not really the same thing, I know. It's working on the same project. So I thought I would do this to mix things up a little bit. Give it a little bit of a, a different thing. So I'm just going to clamp this on here temporarily. This. And then, like I said, that'll go up there. I really need that wheel on, though. I really need to have that wheel on there. I should have screwed that, or I should have double-sided taped that on. Okay, so you can see the way this works. I think that this whole arm arrangement here can actually come in a bit further to give me more of a mechanical advantage for the lever thing here to put tension on it. I actually think I could have made this arm here a bit longer too. So what I'll do is I'll move this further in quickly. A couple inches, that's all. Maybe? I don't know. See, ideally, the front of this bearing should line up with the front of that, so you get a nice vertical area for the belt for you to use the belt. So if that's the case, then this is only sticking out about an inch on the back. So I can come in a bit further, actually. And I think that'll work better. The idea is to hinge this very similarly to the way I did on my one here. I put a hinge on it, that tips, and then the whole thing lifts up and down. But in this case, rather than having rather than having the whole thing lift up and down, which would be more accurate, but a little bit more complex, I'm going to make it tilt, and it'll pivot right on the hinge. There'll be a single screw in the hinge that'll go in here, and it'll tip back and forth on that. It will be possibly a little bit more difficult to line up, but it will be a lot simpler to build, and also it should hold its adjustment fairly well too. So I'm going to find a hinge. Yeah, this gets screwed on like that, front of the hinge onto the back of this thing here. So I got to put screws in here, and I've got short ones. I already mentioned that, so I'll have to edit that out. Or maybe I'll leave it in. So I'll drive those in. They stick out a little bit. So what I would do for the final build is actually countersink in these holes a little bit with a drill bit or a countersink, and that will make them sit more flush. So I'm going to get 3 in there, and then I'm going to use a longer one to attach it to the post where it goes, and I'll line that up next. I mentioned something about when you get older, you don't like to bend over. So it's like a wash of dread goes through you whenever you drop something on the floor that you have to pick up. Okay, I've got a screw here, and it's 1.5 inches, which should work okay. I'm going to take my belt, put it on the drive wheel, thusly. I'm going to drape it up over that, and then I'm going to hold this relatively level and relatively tense too. I can't put too much tension on this, or I will pull that wheel right off the peel and stick tape. So that looks fairly plumb, and I'll just drive the screw in. Okay, I'll make it tight, and then I'll take my screwdriver and I'll just slack it off a little bit. Wrong tip. Just like a 1/4 turn, so it's free to move up and down. So you can see that will put the tension on the belt. I'm going to make an adjuster here that pulls this up and down, and then it'll be able to tilt like this. The only problem that I foresee is that it can't go back further that way, so I might have to pad the hinge out on the bottom here, put a block of wood behind it so it actually pushes it out further, so this part can tip back in further. And I'm pretty sure that's what I did on my thing there. Yeah, I think it has room to move in and out. And then, there'll be a screw to adjust this. The only difference between this and that is that the screw can push it out, and that will track it. And then the belt tension itself would pull it back in. Here I've got the opposite. I'm going to have to pull this in tighter, and that'll work against the belt tension, not with it. So, but then I can't arrange this in the same way as I can arrange that, because you're kind of constrained to what you have here. Anyway, I think it's going to work good. I just need to make allowances for that movement when you tilt it down to, change the belt, and tilt it back up again to tension it. Okay, I added a 1/4 inch shim behind the hinge here, and it allows the thing to tilt right back in, maybe, I don't know, as much as 10 degrees. And I was thinking about how I can make that adjustable, and I talked about how that one works with the belt tension to press it in. So I decided to actually add a Y-shaped piece here that will go up over, and then I'll be able to put an adjustment screw in here that will simply just push on the side of this to make that adjustment. And then you'll just put a rub plate in there, very similar to what I have on mine, and that'll push it back and forth. So simple. The only thing I got to do, though, is make sure that it clears the belt as it goes up. So I'll get this put on. Once again, a situation where it'd be great to have another arm. Maybe I should do the Doc-Ock thing and build a mechanical arm for myself so that I can do these complicated things. I wonder what the chances are of that video doing well. I think there's a guy out there that's doing that kind of thing, though. He's building like exoskeletons that will help you lift heavy things. I think that's a very good way to break your back, though. Wow, my bandsaw is making a lot of noise. Maybe I should do something with that. That's going to go on here. That should clear the belt. Let me get the belt on again. See, it'd be great if I had a clamp up here to hold that on, but that won't work either. Yeah, I think that'll work. I have to leave it down low enough. No, I can put it right up tight against that wooden block there. That'll be fine. But it has to clear the hinge as it tilts back and forth, which is not going to be very much. I mean, that doesn't have to move very far to take the tension off of that completely, or lift up very far to put a lot of tension on there. So I'm just going to screw this thing on with a couple of 2-inch screws. And then what I'll do is I'll put a piece of 3/4 inch plywood on the outside, and that will have the adjustment screw in it. Okay, I've got the block mounted, and I've cut a piece of plywood that I drilled a 5/16 inch hole in. I've got a 1/4-20 bolt, and I've got a 1/4 inch T-nut that I'm going to drive in here now, and then I'm going to mount that on there. And then, like I say, that'll push. You'll be able to adjust that in and out, so they'll push on that arm that goes back and forth, and then it'll adjust the tracking. All right, so that goes on there. And I can screw that on. I guess the best place for that to push is as close to the top of this thing as possible. Like I said, all this is just a mock-up. I'm not sure if this is the final size of different things. Most likely it won't be. I think that this arm here should actually be a little bit narrower. And then, but the base and all that seems to be coming together well. The only changes that I would make to it are ones that will make it look better and more compact. Because you don't want to be storing something that's, you know, very bulky. Put that on there. Another screw in there. Yeah, this is the kind of solution that I really like to come up with. You know, it's easy enough to get stuck on this to say, okay, well, I need something that's going to pull that in, when you can easily add more crap to the other side over here to make it work the way you want it to. And this is a much more efficient method of working. And it, you know, it moves freely there. The only problem I've got right now is that this piece that I just put on here is touching the belt, so I'll have to trim that off. Ow, I walked right into that chop saw. Oh, I don't know how many times I've done that. It kills me. Chop saw, table saw. New arrangement is chop saw here, table saw over against that other wall, open space between the two, so I can walk around here without, you know, killing myself. Okay, I turned down the speed on the lathe just to give this a quick test to see if it actually, you know, flies off. And we'll give it a go. Got some tension put on here. Tension mechanism's not in place yet. As you can see, it still comes down. But this will give me an idea if it's actually going to work properly. Okay, it's tracking inwards. So if I slack off this screw, and now it's tracking back out. Yeah, that's going to work great. I just need something to put tension on it. And this wheel down here is not exactly centered on the faceplate either, so improve upon that when I make the new wheel. Okay, I'm looking at this and I'm trying to come up with the best way to do the tensioning. I've got two choices here. I've actually got three choices. One popular way to tension these things is just to use a spring. And that's tempting, but whenever I build something, I want to make sure that I use parts, especially for something that I make plans for. I want to use parts that you can easily obtain. I don't want to use anything that you have to use that's special, like a special part like a spring that you might have trouble tracking down. I mean, springs are not just springs; they've got different tensions and whatnot. So you really need to have a specific size in mind for it. The other way I could do this, and that's the way I did mine, and that's to pull down on this end of it. So I can rig up a linkage that you can tighten like a wing nut up here, and it will pull it down and put tension on it. It needs to be able to move back and forth a small amount for the tracking, so it has to be a little bit slack up here for that. The other way is exactly the same way that I did with this over here. I could put something on top that cantilevers over, and I can actually push down on it with a knob up on top. I think that's actually the easiest way and probably the best way for this one. When looking at this problem in particular, I realized that a better shape for the post, rather than making it straight like this, would be C-shaped, so that it actually sticks out a little bit further here, and then it swings back in over the rear here a little bit, and then comes back down to the base. And that way I can hinge this arm up here closer to where the upper wheel is, and it'll give me more mechanical advantage over here, more easily, that is. And it'll also give me a point pretty much straight down to attach a tensioner that would attach to the frame underneath to pull it down, which would simplify a lot of things. But like I said, for this one, I'm going to just screw on a piece of plywood above here and drop a screw with a T-nut down to put tension on the back of the arm here. I've got the block made with the T-nut, exactly the same as I did here. And I've got a carriage bolt in it this time because it's longer. I've also glued a small plywood pad onto here, and that will give me a flat surface for this to rub on as I push it down or I screw it down. So I'll just get these screws driven in to the top of the post. I'm undecided as to whether this part or this method should be the final one. I got to see how well it works. It is very simple and elegant, and for that reason I do like it. Okay, so you can see how that works. You just turn that and it pushes this down, it lifts that up, and it puts tension on here. But before I do anything else, what I need to do is I either need to make the new drive wheel or I need to attach this one to the faceplate and then turn it down so that it actually, it's actually true. I think I'll do that just as a test and try it out again. I've taken the lower drive wheel off and I took the double-sided tape out, took the faceplate off, screwed the faceplate onto the drive wheel. Now I'm going to true it up quickly because it's a little bit off. It's not that far off, but enough to make everything wonky. I just got my favorite 1/4-inch turning chisel. Now I could crown this, but I don't think that actually makes a difference when you have tracking. A lot of people ask about that. I'll turn this off so you can hear me more clearly. A lot of people ask me about that, where the belt grinder and the small strip sander, when you've got tracking, you really don't need to crown the wheels as much. It doesn't hurt, of course, but it's not really necessary. crowning them will help the center them, but it's the tracking that moves the belt back and forth and positions it correctly. So I'll put a little bit of a crown on this, but not much. Mainly what I'm looking for is just to make it perfectly round. Isn't this fun? I like turning, actually. I've done quite a bit of it in the past. I made an entire chess set one time when I was much younger, and that wasn't even on a real lathe. No, it was on a real lathe. It was after I had a real lathe, or real-ish. Well, as real as this thing is anyway. I made the pieces from walnut and maple, and I hand-carved the knights, and they kind of look a little bit like dogs, carriers, but nice result overall. And what I did was I put it in a gift shop to sell on consignment, and one day they just disappeared. They took my chess table with them, because it was a set. It was a table top. It was a full table, you know, with drawers to put the pieces in, really ornate. A lot of work, and they just frigged off with it. Rogues. Okay, I think that's good. I've got the thing put back on, and I've kind of adjusted it up here a bit. I've also added a block underneath the lathe bed, just a block of plywood, and I screwed down through the base to lock down this side. And if I try to move this here, it's very solid. It's as solid as it needs to be. So I know that this bracing method and this overall configuration is strong enough for this. I've got some tension put on the belt. I think I actually have enough tension on the belt. These things do not have to be very tight. Okay, I already had it running, and I started it up again, and I'll show basically how it needs to be adjusted. Right now it's perfect, but this one adjusts the tracking. If I slack it off, the belt will track that way. This one adjusts tension. If I slack that off, it gets looser. But what also happens is it adjusts the tracking a little bit because of this configuration. So you more or less have to adjust these together. Give it some tension, adjust the tracking, more tension, more tracking, until you arrive at the right configuration. Looks good there, and I gotta believe that it'll probably stay there. The next step, of course, is I'm gonna just turn up the speed here a little bit. Right now it's running at 1260 RPMs. I'm gonna calculate what the surface speed of the belt is for that. I put it on the screen here, and the maximum this lathe will go to is 2400. I'm going to try that. I actually have bits of grit coming off the belt and flicking at me, so I don't know if that's too fast or... That's 10. That's as fast as it can go. And I have to believe that that's actually fast enough for grinding steel, so... Pretty versatile arrangement here with a very cheap lathe. I think I paid $399 for this about, I don't know, 7 or 8 years ago. And, you know, you can rig this thing up here basically from junk you've got laying around, scraps, like I have it right now, without the tool rest and the backer. It works fine. You can do some rudimentary shaping on it just as it is. Well, for the backer plate for the belt, I've got a piece of aluminum that I would use in the final version, but I'm not going to use it here, basically because it's a waste of time cutting that out twice, because I would have to cut it out again for the final version just to show it in the video. So what I'm going to use for this is plywood. And I'm looking at the arrangement here for the tool rest. And I would like to keep that as simple as possible. The best arrangement for any tool rest is a trunnion type thing, and that will automatically put the fence or the table at the right angle or the right distance from the belt as you adjust it. and it's the kind of arrangement you see on a table saw. But I came up with a different one for a much simpler one for my strip sander that relies on moving it in and out as you adjust it to position it closer to the fence as you angle it down. The backer plate really needs to be thin and it needs to be stiff for to be able to get in tight to something. I mean, you've got this space here, and if this was C-shaped like the final version would be, you'd have all this space inside here to get in with a part so that you could sand the inside like of a C-shaped thing, and it could be really thin and you can get in there. But the problem comes when you want to mount that. So I've got the plywood that comes up here for the support table. That's fine. And in my other design, that bracket actually mounted right to the face of that table. And I think that's actually the best arrangement. It was a Z-shaped so that it would, screw onto the front of that and then would zig over behind this and stick up. So it was completely clear. And I can't think of a better way to do that. So what I'm going to do right now is I'm going to take this all off again, and I'm going to replace this thin plywood with a thicker piece, 3/4 inch, and I'm going to make a temporary, or a kind of a makeshift backer plate out of 1/4 inch plywood that's Z-shaped like I talked about, and fix that on there. And then I'll make the L-shaped table that will work with that. And I dropped the screw again, so that means another trip down to the floor. Okay, I've got a situation here where, remember, I wanted to have this part plumb, straight up and down. And I see now that it's kind of leaning back. And that's because I resized this wheel. I made it a little bit smaller. So that made this arm come up more, and it threw it back a little bit further. Along with that, I wasn't really precise in placing it, so I got kind of a problem. And I think my solution is to move this arm ahead by about, looks like 1/2 inch. And my tensioner will still work by the looks of it, still catching on that pad up there. These are the situations that you come across or run into every time you do something like this, and you try to work them out before you do that, but it's almost impossible to see everything before it happens. And that's why one of these prototypes, even though it's as rough as this, and I've done this time and again, everything I've built here that I have plans for, with the exception, I think, of the cabinet up here, I've already made prototypes for it to check to make sure that they work properly. Certainly any machine. My box joint jigs went through dozens of changes and builds, prototypes before any plans were made for them. So yeah, so I'm going to quickly do that, fix that up, and see if that corrects it there. Okay, I got that done. I had to move a few other things too. Not a big deal because everything's just screwed on there, not glued, which makes it very adjustable. I also relented on making the backing plate because even when I did do it, I saw that I don't have enough space there for 1/4 inch plywood. So I'm going to go ahead and cut the aluminum piece for it. This will probably be the one in the final build. I won't cut it out again for the final build. I'll just kind of fake it, which is something you can do with video. Since you don't have to show all of the cutting operation, I'll just show the first part and bang, the part's done and it's on the machine. And nobody's the wiser except if they watch this video. Looking at this, I'm fairly certain I won't use this in the final build because it's kind of rough. I was not careful cutting out and probably won't line up with whatever configuration I decide on anyway. So this goes on here and it just gets screwed on. To avoid splitting the plywood, I'm going to drill pilot holes. Part of the way in. They don't have to go all the way in. When you drill them all the way in, it kind of affects how well the screw grabs. But if you just drill the first, say, inch, if you're putting an 1.5 inch screw in there, that'll stop it from splitting because it takes the pressure off the first part there. And you really want longer screws on something like that. You really want good anchorage into the wood when you screw this thing on. Actually, 2-inch screws would probably be a lot better. But for this prototype, 1-inch ones will do. Now the important part of this plate is that it clears this wheel and it fits behind this belt without really contacting it. And I think I have that here. It looks pretty good. Really, when you're sanding, you want this to be running proud of the surface of this plate by just a very small amount so that it's not, wearing the back of the belt. And then when you push something in, it'll push it right into the plate. Also, having a little bit of give in that, I think, is a good thing too. Because it's a rigid plate, but it has some give so that it's not chattering too much. If it's really stiff, what you'll get is a problem that I have on my belt grinder. Actually, the join where the belt joins is a little bit thicker, so there's like a bump there every time it hits the really solid, not moving platen. It'll bump there and it'll bump the piece that you're grinding. So better to have some flexibility. At this point, I've taken the machine to the point where it works, and I don't need to go any further, but just for the sake of demonstration, I added the backer plate, and I also rigged up a quick and dirty table, and that works like this, the same way as the one on my strip sander does. Like I say, you'll be able to adjust the angle by tilting it like this. There'll be a slot cut in this so that it'll move, and rather than a square cut on the inside here, it'll be angled so it'll conform tightly to the belt. But in the meantime, I'm just going to screw that in place so that we can give this a test drive. See that part there where I said we can give this a test drive? That's where I normally cut, and then I reposition the camera to show me screwing in the thing. And this is the way I program my brain to work, so I can't, quite get out of it for doing this kind of thing. So I'm just going to go ahead and screw this on, and I may or may not leave that last part in the video. And if you're wondering what the last part was, it really doesn't matter. I'm going to use a couple of 2 or 1 1/4 inch screws to hold that on there. And then I think everything's lined up and tracking properly. Looks good. Now I'll move the camera. Okay, the moment of truth. Boy. It sands. Thin stuff. Thin hardwood. Thicker spruce. Wow. Nice. I think what it really needs is some kind of shroud up over the top here, because that's pulling the dust right up and throwing it back in my face. You can see that in the camera. Also, some kind of chute down in the bottom here to either passively catch the dust in a small container, or to hook a vacuum up to it. Vacuum would probably be a lot better. But as you can see, it works great. It's at 1260. I'll jack the speed. You can hear the motor bogging down a little bit, not bad. So yeah, pretty good. I'm happy with it. Like I said in the beginning, let me know in the comments what you think of this format of video. I'm not saying that this will become, the regular thing, but I'm thinking about doing it certainly for all of the ones that I do for this series here, where I'm making machines that work on a lathe. Go through the prototype build in the same way as this, before I do the actual build itself. So let me know in the comments. I'm absolutely happy with how this is working out. I'm thinking that I've wasted my time and effort making or gluing the two pieces of MDF together to make the thicker drive block for it. I think that the 3/4 inch plywood is doing just fine. It's tracking perfectly. The bearings up here are working fantastically. You can't really get it any simpler than this. This, I think, is a 2.5 inch bolt, just a regular hex bolt, 1/4 inch. Some washers there to bolt it onto just a rectangular cut plywood. This is exactly the way I like to build things. Very simple cuts, no curves, no patterns to glue on or stuff like that. All just straight measurements and easy to build, easy to put together, and easy to use when you do.